Hello ladies and gentlemen, for this video we'll be looking at surds, some of the rules of surds, and finally how to rationalize surds. Okay, so looking at your first example question here, when asked to simplify the double brackets both including surds, giving your answer in the form of a plus b surd c, where a, b, c are integers, what you're supposed to do is you're supposed to open up this double bracket as if you were opening up your normal quadratic equations, like so. Okay, so the first multiplication is when 4 times surd 2. As you can see from my examples given here, if you have surd 2 times surd 2, that would result in just 2. Okay, so the first multiplication is 4 times 2. Okay, the next one, when you have minus 3 surd 5 times surd 2, you would actually end up with 3 multiplied by surd 5 multiplied by surd 2. Okay, then the next one, this times this, you have plus 2 times 4, 8, and then surd 5 times surd 2. And lastly, this times this, where you have minus 2 times 5, because it's surd 5 times surd 5, right? Then only from here do you try to simplify the like terms. This will become 8. This is minus 3 times surd 5 times surd 2. If we follow this first rule over here, surd 5 times surd 2 is going to turn into surd 10. Okay? Plus with this is the same thing, 8 surd 10, and this is minus 10. All right? Oh, sorry, I missed out the 3 here. It's supposed to be 2 times 3, which is 6. Okay, then surd 5 times surd 5. So it's 6 times 5, which would result in 30, minus 30 here, right? And as you can see from now, all you can do is group up the like terms. You can even treat the surds, right, as if you were writing minus 3x plus 8x, which would result in what? Result in 5x, right? Same case here. This will be 5 surd 10. 8 minus 30, you have negative 22 plus 5 surd 10. Then this will be your final answer, which is in the format of a plus bx plus c, where a is equals to minus 22, b is equals to 5, and c is equals to 10. Okay. Next question. Simplify 4 minus 3 surd 6 over surd 3 plus surd 2, giving your answers in the form of p surd 3 plus q surd 2. What I can straight away tell from this question is we're basically trying to rationalize the denominator. Why do we say that it's called rationalize? It's because surd numbers are irrational numbers. So in order for us to rationalize the denominator, it will no longer be a surd value. Now, in order for us to rationalize anything, all you have to do is change the symbol at the bottom and then make it the opposite, okay? Why would this still count as the same equation? Is because if you look at the example that I've given here, 1 plus surd 4 over 1 plus surd 4, this is just basically this whole thing times 1. That means we are not changing the original value of your surd, okay? So let's try to rationalize this surd value here. 4 minus 3 surd 6 over surd 3 plus surd 2 multiplied by both surd 3 minus surd 2 over surd 3 minus surd 2. Now make sure to bracket where needed so that you do not confuse yourself. From here, expand the bracket. 4 times surd 3, 4 surd 3, 4 times surd 2 minus 4 surd 2, minus 3 surd 6 times surd 3, you have minus 3 surd 6 surd 3, and this times this, you would have plus 3 surd 6 surd 2. I'll simplify everything one shot later. Over what we have at the bottom is surd 3 times surd 3, you have just 3, okay? Then surd 3 minus surd 2, you have minus surd 3 times surd 2 plus surd 3 times surd 2. And then lastly, this times this, which is just minus 2. Okay, cert2 times cert2, right? Now you will notice that when rationalizing, the component in the middle will always cancel out each other. Okay, so when I simplify this full equation, I would have gotten 4 cert3 minus 4 cert2 minus this will therefore change into cert3 cert18 and plus 3 cert12 over just 1. Okay, so we don't even need to write that. It's just over 1. Now, from here, what we need to do is we need to use the breakup rule, which is the opposite of what I've shown here. Cert 18 can be changed into cert 3 times cert 6. Maybe not. Maybe cert 2 times cert 9. Okay, so I'll just leave that. Change this into this because they are the same value, and change this into plus 3 cert 3 cert 4. Okay, this is still the same value here, isn't it? But once we've changed it to this value here, we could actually further simplify the equation. So we rewrite what we had at the front. Okay, cert 9 will therefore turn into 3. 3 times 3, 3 times 3 is minus 9, cert 2, and then cert 4 will change into 2, so 2 times 3 plus 6 cert 3. Then from here, what we have would be just cert 2s and cert 3 as according to what the question asked from us. Okay, group up the like terms, you would then end up having 10 cert 3 minus 13 cert 2. And that would be your P and Q value. P is equals to 10 and Q is equals to negative 13. Okay? Okay, next question. Sometimes the questions will say, do not use a calculator in this question. What that basically means is they're asking you to show all your working. Okay? Doesn't mean that you shouldn't use your calculator to check your answer, okay? So from here, what we want to do is we want to simplify this using the breakup rule that we just tried using earlier. So maybe we will try to find a whole number, a perfect square number out of this. Say I have 4, cert 4, then 128 divided by 4 is going to be 38. Okay, sorry, 37, isn't it? 37. Okay, sorry, 32. 32. All right, 32 over this will be I think I can bring out 9, so it's cert 9 over cert times cert 8. Cert 9 times cert 8. 8, 9, 7, 2. Yep, correct. Okay, and then from here we can simplify this equation to change it into 2 cert 32. Cert 32, maybe I'll bring out another square number. I can take out another cert 4, and I'll be left with cert 8 over here. And then 9 will change into 3, cert 8. From here, what we can do is I can actually cancel off the cert 8s and cert 8, and I would be only left with cert 4 is still 2, then this is just 2 times 2, 4 over 3. And this will be the simplest form. We can even write it as a mixed fraction, 1 and 1 over 3. Done. Okay, and then just so you know that your answer is correct, use your calculator, cert 128 divided by cert 72, and indeed we have gotten 1 and 1 over 3. So you know that your answer is absolutely correct. Okay, now this next question here, simplify, giving your answer as a fraction with an integer denominator. Once again, they are asking us to rationalize this cert fraction here. Now, to do this, what we first must do is make it into a single fraction. So changing it into a single fraction, 1, this times here, 1, 3 plus 2 cert 3 minus cert 3 multiplied by 1 plus cert 3 over the cross multiply of each other, 1 plus cert 3 multiplied by 3 plus 2 cert 3. Okay. Open up your brackets properly. You would have 3 plus 2 surd 3 minus surd 3, and then this times this is minus 3, okay, over this times this 3 plus 2 surd 3 plus 3 surd 3, and then finally 3 times 2, 2 times 3, okay. From here, we would be able to simplify the top. You're only left with surd 3, and at the bottom, you have, this is 6 plus 3, 9 plus 5 surd 3. Okay, then from here, rationalize the denominator. You should have surd 3 over 9 plus 5 surd 3 multiplied by 9, 5 surd 3 over 9 minus 5 surd 3. Okay, and then expand these brackets over here. You would have gotten 9 surd 3 minus 5 times surd 3, which is just 5 times 3, 15, over 9, 81, 5, 25 times 3, so it's minus 75. Okay, minus 75. And then your final answer, I think, should be 9 surd 3 minus 15 over 6. You would have therefore changed the fraction into an integer denominator. And you'll be done. One more example for rationalization. Basically, again, still using this rule here. 5 plus 6 surd 5 over 6 plus surd 5 multiplied by 6 minus surd 5 over 6 minus surd 5. Okay. Rationalize this. 5, 5, 30. 5 minus surd 5 minus 5 surd 5. 6, 6, 36 plus 36 surd 5. And lastly, this times this. 6 times 5 is minus 30 over 6 times 6, 36. And then surd 5 times surd 5, minus 5. Finally, grouping up the like terms, 30 minus 30, 0, minus 5 plus 36, you will be left with 31 surd 5 over 31, which you can further simplify by eliminating the 31, and that would just leave this value as surd 5. Okay? And then these questions here are just basically some of your indices combination questions with surds in it. Show that 3 to the power of 0.5 times surd 2, 7 to the power of 7 can be written in the form a surd b, where a and b are integers, and then the condition is a must be bigger than b. Okay? What I can do is I need to know that this 3 to the power of 0.5 is basically 3 to the power of half, which is also known as square root of 3. Okay? And this is surd 2 to the power of 7, right? Meaning to say multiply by surd 2 times surd 2 times surd 2 times surd 2 times surd 2, 1, 2, 3, 4, 5, 6, and 7. Okay? Now, what you can see from here is if I have this times this would just be 2. This times this would become 2. This times this would become 2. And then this times this would become surd 6. So from here, all I have to do is do the basic calculation. 4, 2, 8, surd 6 would be my final answer here. Therefore, fulfilling the condition of A bigger than B. A bigger than B. All right. One last part here. Solve the equation x plus surd 2 equals to 4 over x. Basically, change it back into a quadratic equation. You would have x squared minus surd 2x equals to 4, bring over becomes minus 4 equals to 0. Okay, giving your answer in the simplest surd form, meaning to say we must use our quadratic equation where x is equals to negative b plus minus the square root of b squared minus 4ac over 2a. Substituting our values into the formula here, negative square root of negative square root 2, okay, plus minus the square root of b squared, which is basically square root 2 square, okay, minus 4ac over 2a, which is 2, 1. Simplify this whole thing, you would have surd 2 either plus or minus the square root of square would cancel off each other, including the negative. So you have 2 minus 4 times 1 minus 4 times 1. You have plus 16 over 2. Okay? And therefore, your final answer should be square root 2 plus minus the square root of 18 over 2. Maybe I can even change this up into square root 2 plus minus square root 9 times square root 2, which is square root 18, right? Over 2. Then this will just be square root 2 plus minus 3 square root 2 over 2. And this can be your final answer here. Okay. Or if you want, you can break them down into square root 2 plus square root 2, you have 4 square root 2 over 2. Or square root 2 minus 3 square root 2, you have minus 2 square root 2 over 2. So this just becomes 2 square root 2 or negative square root 2 will be your final answer. Final answer here. Right? Hope this video helped you guys. Thank you.